Okay, so I'm going to talk about a pretty basic example of retrofitting, what repairing a bridge implies in our country. The structure I'm going to talk about is on National Road 65C, a secondary national road for Romania, but one with pretty high traffic because it's the most direct link from the center of the country through Old Gorj and to the city of Craiova, which is one of the biggest in Romania. This is probably why, although it's a secondary road, the bridge was included in a general repair program in the area around Craiova for a number of structures. So at kilometer 74 plus 853, there's a bridge over Cerna River, built approximately around the 1970s. So it's about 50 years old. It was made of reinforced concrete with a total length of 80.5 meters. And it's a frame from the static point of view, a 7-span frame with spans of 3 meters, 8.50, 21.5, 14.50, and again, it's mirrored. What was interesting for me at the time is that the piers are in the shape of the letter Y, and it has no abutments. It was a solution very often used at that time. The width of the carriageway is 6.90 meters, which is smaller than typical Romanian bridges right now. And there are no safety features. There are no guardrails. There are no pedestrian protection from the carriageway. So it had a few problems from the functional point of view, but it had a lot of problems from the structural point of view, as you will see right now. So basically, instead of abutments, there were some retaining walls made of wood. The bed level of the bridge of the river was lowered about 2 meters, exposing the foundations. And most importantly, in the nodes area, the concrete was expelled and the main reinforcement was visible. Basically, you could pull it by hand from the concrete. So it was very dangerous from this point of view and not very safe. The first solution we thought of was just to demolish the bridge and just build a new one. But this was not accepted by the client, by the beneficiary, due to problems in budget and due to the fact that they really wanted to keep the bridge and have some continuation of National Road 65C rather than just close it. So they told us to do a retrofit of the bridge and to increase its parameters, to increase the carriageway to 7.80 meters, which is standard for Romanian national roads, to add safety features like pedestrian guardrails and road guardrails, and also to come up with a solution for the river, to protect the river banks and the exposed foundations. For the river part, we added a threshold to raise the water levels and protect the foundations. We also reinforced the foundations from seismic point of view and from water protection point of view. And for the superstructures, one of the demands of the client was to raise the capacity to European norms. In the 1970s, bridges were designed by older norms, as Japan, and they required for us to bring the bridge up to date. So the most common solution for this was to use an external pre-stressing system. which is very efficient typically, but is very difficult to apply on some bridges, particularly frames. This is not an isostatic bridge, so if you're not careful, external pre-stressing can do more harm than good. Naturally, we had some 3D element models. Another problem when retrofitting existing bridges is that we don't have the documentation from the initial construction of the bridge. So there's no way to tell how much reinforcement was used at the initial construction, aside from doing an analysis based on the old norms. So this is what we did. We did an assessment of the bridge, an estimation of the existing reinforcement. We removed the exposed reinforcement, which we considered was not working with the structure anymore. And then we added our pre-stressing system and compared the values. We ended up with, I didn't mention this, the bridge in cross-section was made up of two beams, reinforced concrete, two rectangular beams, and we added two cables, each cable having 19 strands on each side, resulting in a total pre-stressing force of almost 4,000 kilonewtons. We had some issues with the lateral piers because of the pre-stressing. Some other moments and axial forces appeared which were not intended in the structure, so we had to retrofit them as well. Now, during the construction, external pre-stressing is quite difficult. They had to construct a temporary passageway for workers to work underneath. They had to do some anchorages and deflectors out of concrete fixed to the existing structure via transverse pre-stressing with pre-stressing bars. A lot of scaffolding, a lot of local repairs, especially in the nodes area. And when they finished the anchorages, they had to install the main cables, which was also a challenge because there was no room to install the cables from the side of the bridge. Luckily, since the bridge had no abutments, they simply dug out the earth behind the bridge and installed the cables. And then they built some abutments. Okay, these are photos from the end of the works. Everything was turned out to be okay. We monitored the stress levels in the superstructure during the pre-stressing of the main cables with topographic marks. Basically, after each pre-stressing stage, we rechecked the sag of the structure, and we had an error of about 0.93, so it was acceptable, plus minus 7% of what we estimated. So we were pretty pleased with that. Afterwards, they added the pavement, the guardrails, and so on. Now I'm going to wrap this up because this is a pretty simple example compared to what we've seen today. As you can see some photos on the bottom of the presentation, aerial photos of the existing bridge initially and after the retrofit, and on the right side, some pictures before, during, and after construction. The internal stresses increased to about 35% because of the added carriageway, the new load models according to Eurocodes. I can say the procedure was a success, but it was very costly in the end. It exceeded the initial budget. As a side note, the first assessment of the bridge was done in 2017, and the works were completed in 2023. So it took about 6 years to complete, period in which prices increased due to the local conditions due to the war and etc. I can't say if it was a good idea right now to repair the bridge or if it would have been better to just demolish and build a new one, considering the bridge should have no more than 50 years lifespan, considering all the maintenance work will be done. But due to budget problems and the situation, this is what we did. So if you have any questions, otherwise, thank you for your attention.